Hello, this is a short video about a wearable badge I made for the last EMF camp. It is a severely crippled version of a bigger CPU project I made earlier, and it's crippled to the point of not being useful anymore at all. It's completely useless, just meant as a joke really. So it has a number of transistors on site. On the top, each of these black things dipped in fluorescent paint is a transistor. There's an LED showing the data bit activity and 3 more LEDs showing clock activity. If you press a button, it runs a little program for a while. The LED there shows the data bit activity and the other ones show the clock activity. So let's take a look at how this works and what it is and what the transistors do. So the CPU is implemented on the front. All these transistors on the front form this little circuit on the paper. And let's start off with a data line corresponding to that LED there. So first, in each instruction, the data is latched and inverted by the latch on the right. The output of the latch then decides between 2 possible new values for the program counter. The first option is the current program counter plus 1. So in this crippled version, the program counter is only 1 bit wide. So adding 1 is the same as inverting it, so I chose a simple inverter instead of an adder there to make it a bit simpler. Second option for the new program counter is a branch address, so a jump address. So each instruction the CPU decides between program counter plus 1 or branch address as next program counter value. These 2 latches only exist to avoid the program counter value from spinning around, so they open up in turn. So if you count the number of transistors in each block, the data latch has 8 transistors, the multiplexer has 7, the inverter there consists of 1 single transistor, and each of the 2 address latches on the latch on the left have 11 transistors, making up for a total of 38 in this version. Now the CPU has 3 I/O ports: the program counter, branch input and data I/O line. So that circuit is implemented on the front using transistors. However, the rest of the computer system is implemented on the back of the PCB and consists of a ROM and a RAM, an emulated ROM and RAM. So together, the front of the PCB containing the CPU and the back of the PCB containing the ROM and RAM form a little computer system, let's say that. So that's at the back. The ROM addresses the RAM, which is a bit weird maybe. The ROM contains instructions. Each instruction contains 2 operands. First operand is a branch address, the second operand is a data address. The RAM is connected to the CPU using the data line, and the CPU can read from the RAM or write to the RAM. Now, not everything happens at once. There are 3 clock inputs corresponding to the 3 LEDs at the front. First clock input, second input, third input. So let's see what happens when. The first clock pulse on the first line, the data latch is activated. So that happens first, each instruction cycle. Then the topmost address latch is opened. That happens next. And finally, in an instruction, the bottommost address latch is opened. So that happens last. And each instruction, all these things happen in that order. So first, data latch activated, address latch activated, other address latch activated, and so on, and so on, and so on. So each instruction does 3 different things in turn. So to make it a bit more interesting, the LED that you saw blinking on the front corresponds to 1 data bit. So it shows the state of 1 data bit, a random data bit in RAM. So the program counter in this crippled version is only 1 bit wide, and each instruction in the program has 2 operands. The left operand is a branch address and the second operand is a data address. So if you have 2 instructions with 2 operands, you can make 16 possible programs. So that's all this thing can do, really, run one of 16 programs. So each of these programs generates a different pattern on the data bits in RAM. So if you take a look at one data bit, you can form 5 different patterns. So in this case, I simply chose to run the simplest program showing the most activity, and that is the topmost pattern. So that's basically how it works. Thank you very much for watching, and goodbye.